Welcome back to another Forge College Explainer. Since you guys absolutely crushed the capstone build last time, today we're drawing up the architectural blueprints for a massive conceptual shift. Grab your hard hats, because we are mapping exactly how Ethereum token standards, like your beloved ERC-20s, actually translate over to Solana.
So let's dive right in. You already know that moving from the EVM to the SVM requires some serious rewiring. But you might be thinking, why can't I just take my perfectly good Solidity contract, run it through a translator, and call it a day? Well, trying to port your token logic one-to-one is a recipe for a massive headache. It's not just a different language, it's a completely different paradigm of how state and logic interact.
Here's the structural blueprint we're looking at today. 1. The migration blueprint. 2. Shops versus malls. 3. Mapping state and metadata. 4. Translating authorities. And 5. Rethinking workflows.
Let's get into it.
Section 1. The Migration Blueprint.
The core difference really boils down to this. On Ethereum, whenever you launch a new token, you're deploying a totally unique, custom smart contract. That contract holds everything: the rules, the supply, user balances, the whole shebang. But on Solana, you rarely, if ever, write a new program just to launch a token. Instead, you reuse a shared, globally available infrastructure called the SPL Token Program. So you're leaning on a highly optimized, universally trusted program rather than uploading custom logic every single time.
Moving on to Section 2. Shops versus malls.
To really grasp this, think of an Ethereum ERC contract as a standalone shop. If you want to sell your brand of t-shirt on Ethereum, you got to buy the land, lay the foundation, build the walls, hire security, and just hope the plumbing doesn't get hacked. You build the entire building. Solana, on the other hand, is like a giant, bustling shopping mall. The walls, the security, the plumbing, it's all already built for you. To sell your t-shirt on Solana, you don't build a new building. You just rent a stall in that massive existing mall. And that mall is the SPL Token Program. So, in our mall metaphor, what exactly is your stall? Well, that's your mint account. A mint account is a record on Solana that describes your particular brand's product. It holds global parameters for your specific token, things like the total supply and the number of decimals. It basically establishes your token's unique identity right there within the shared SPL Token Program mall.
Now, when a customer buys your token, where does it actually go? On Ethereum, their balance gets written down in a ledger in the back room of your standalone shop. But on Solana, the token goes into a token account. Think of a token account as a customer's personal locker located right inside the mall. This locker holds the balances for a specific owner of a specific token.
All right. Section 3. Mapping state and metadata.
Let's map this data out. Your total supply, which used to be an internal variable in your ERC-20 contract, moves directly to the supply field inside the mint count. Your balance of function, that state is now physically separated and stored inside those individual token accounts owned by the users. And your decimals sit inside the mint account. But notice that last piece. What about the token symbol and the name?
Unlike Ethereum, where a token URI function kicks back off-chain JSON right from the contract itself, Solana handles things a bit differently. It typically splits metadata responsibilities off into entirely separate auxiliary programs, most notably the Metaplex Token Metadata Program. The core SPL Token Program stays incredibly lean and fast by only caring about numbers and balances. Honestly, it doesn't care if your token is named Dogecoin or Ethereum Classic. All that rich, bulky metadata is just attached to your mint account via a secondary metadata account.
Now, because state is split into so many different accounts, a mint over here, user lockers over there, finding the right locker could be a total nightmare. And that is exactly why you have to manage associated token accounts, or ATAs. An ATA is a deterministically derived token account. Essentially, it's a standardized address formula ensuring tokens are routed to the exact right customer locker. When someone sends you a token on Solana, they aren't sending it to your main wallet address. They're sending it to your ATA, your specific locker for that specific token.
Section 4. Translating authorities.
If your old EVM shop had an only owner modifier, a built-in role dictating who could mint new tokens or freeze transfers, on Solana, that becomes a mall-level guardrail. Because you don't own the SPL token program, you interact with it using specific keys. You have mint authorities and freeze authorities. These are simply key pairs or multisigs that the SPL program recognizes. It's kind of like giving a specific badge to a mall security guard. The program checks the badge, not an internal variable in a smart contract.
Even your standard ERC-20 approvals translate directly, but mechanically they're a bit different. On Ethereum, you'd call approve on the contract to update its internal ledger, telling it a DeFi protocol can spend your tokens. But on Solana, you set an explicit delegate authority right there on the user's token account locker. You are literally appending a temporary guest pass to the locker itself, rather than updating some master ledger in the back of a shop.
Finally, Section 5, Rethinking Workflows. On Ethereum, your test suites probably deployed a fresh, disposable ERC-20 contract for every single test case, right? Well, on Solana, you don't redeploy the SPL Token Program. Instead, your new linear workflow looks like this. Step 1, initialize the mint stall. Step 2, set up the user lockers, the token accounts, for your test participants. And Step 3, invoke the shared mall program's mint instruction using your authority key. It's a fundamental shift from deploying logic to managing account life cycles.
Let's recap the absolutely crucial takeaways here. First off, you're separating behavior from identity. The behavior lives in the SPL program, the identity lives in your mint account. Second, you got to translate your EVM permissions explicitly to cryptographic keys rather than smart contract owner variables. And third, you can finally stop deploying per-token binaries. Start focusing your CI/CD pipelines and your anchor tests on account lifecycles and initialization instead of heavy contract deployments.
This conceptual foundation perfectly sets up our next lesson. Now that we understand the blueprint and the whole mall metaphor, we're going to get our hands dirty with exact account layouts, canonical SPL instructions like initialize mint and mint2, and exactly how those associated token accounts are mathematically derived.
So I leave you with this provocative thought as you write your new anchor scripts. Are you ready to stop building expensive, isolated standalone shops and start powerfully managing your presence in the SVM shopping mall? It takes a shift in perspective, but man, once it clicks, the efficiency is just incredible. Thanks so much for hanging out for this explainer. Be sure to head over to forge.college to dive deeper and master the rest of this Web3 migration journey. Catch you in the next one.